Hi folks, Mr. Long here. I'm going to do a screencast on optimizing surface area. So let's take a look at one of these problems that we worked on today in class. These are hard problems. So we've got a cylinder with a radius of 12 centimeters. So a cylinder with a radius of 12 centimeters, and its surface area is 980.18 centimeters squared. What we want to do is figure out if that's the best shape. So in other words, will that cylinder be the cheapest one to wrap? And so what I've got to do first is figure out, before I do that, I need to figure out what all the dimensions are of that cylinder so I can get the volume. So here we go. So question A says, what is the surface area of the best cylinder having the same volume? Well, if I look there, I don't even know what the volume is, right? So we should start this question like we should start all questions with what are the formulas that we use? Well, we know area of a cylinder is 2 pi r squared plus 2 pi rh, and we know that the volume of a cylinder is pi r squared h. We also know that the area of the best cylinder, which remember was one where the height and the diameter were the same, or the height was double the radius. And oh, just 1 minute, folks. Sorry, I've got a puppy that I can hear my dog barking to get into the office where I'm working. So anyway, the area of the best cylinder, that formula is 6 pi r squared. And then the formula for the best volume is 2 pi r cubed. Okay, so those are the four main formulas that we're going to use. I'll call that one 1, I'll call that one 2, I'll call that one 3, and I'll call that one 4. So those are our 4 formulas we're going to use. And again, this is hard, and you may want to pause and rewind. But again, there's a process to this, and it's a step-by-step thing. It just gets you practicing a lot of different skills. Okay, so let's start working on this. So if I look at this, I need to, the question here, I notice that there's no height. All I've got is an area and a radius. So let's take a look at these formulas and see what I know. So let's look at formula number 1. And I'm going to check and see if I know all the variables. So I know the area, it's 980. I know the radius, it's 12. Again, I know the radius, I don't know the height. Okay, so it looks to me like when I have one unknown in an equation, I can figure out what it is. Let's look at the second equation. Because I know this, by the way, this isn't the best cylinder. So that's going to be the volume there. I don't know the volume. I do know the radius. I don't know the height. I can't solve equations when I have 2 unknowns. I can solve equations when I have 1 unknown. And so I'm going to go through, and that tells me that I need to pick the area formula to work with. So I'm going to start by writing down the area formula. Area equals 2 pi r squared plus 2 pi rh. And I know that the radius is 12 centimeters and the area is 980. So I can replace, everywhere where I see radius, I can replace it with 12. 12 squared there, and r is 12 there. And then I know that the area, I also know the area. The area is 980.18. And so that's equal to 2 pi times by 12 squared plus 2 pi times 12 times by h. Okay, so that's the formula. And if you look at that, the only unknown is h. So what I can do is I can put things like 2 pi times 12 squared in my calculator and 2 pi times 12. And I'm going to end up with something like 980.18. Now I'm putting this in my calculator. So that's going to work out to 904.78 plus 75.40h. So that's an equation right there. Oh, and by the way, I guess one of the things I've been trying to get you to work on is you know, I don't think I'll number the equations right now. I don't think I will. Well, actually what I can say is here I put R equals 12, A equals 980.18 into 1, okay? Now I've got an equation to solve, BEDMAS and inverse. So first thing I'm going to do is check BEDMAS. So I start with the variable that I'm trying to figure out, which is h. First thing that gets done to h is it gets multiplied by 75.4. The next thing I'm doing is, so 75.4 multiplies, and then I remember I can read right to left to right with equations, plus 904.78. So then I add 904.78. So I minus 904.78, and I divide by 75.4. That's the inverse. Okay, so those operations apply to 980.18. So I start by minusing 904.78. I get that answer, and then I divide by 75.4. It works out that h equals 1 centimeter. Okay, so now I know the height of that cylinder. So that's my original cylinder. So that's an interesting one because the radius is 12. So half the distance of it is 12, and then it's only 1 centimeter tall. That's the height. This looks like a hockey puck, right? And so if you look at that, again, I should probably make like the cylindrical shape there, and then that's like that at the bottom. So that's not a very efficient shape, right? If I'm going to put, juice or whatever in it. 1 centimeter tall with a radius of 12. And so I know that the area from that was 980.18. I do have to figure out the volume of that shape, though. So the volume of any cylinder is pi r squared h. And I know that for this shape, that's going to be pi times 12 squared times by 1. And the volume is going to be, if I put that into my calculator, that volume will work out to 452.39 centimeters cubed. Okay, you don't need a circle around that. You definitely don't need a circle around that. So that is what we know. So this cylinder here, the strange one, with a radius of 12, a height of 1, has an area of 980.18 and a volume of 452.39 centimeters cubed. So we know that that's not the best. It can't be the best cylinder because the best cylinder, the height and the diameter are the same. Okay, so now we know everything about that original cylinder. We know its volume, its surface area, its radius, and height. Now we need to make the best cylinder. Okay, what's the best cylinder? What's the best cylinder? So we know, in terms of a picture, we know that the best cylinder, it kind of looks like a square, right? Because the height is the same as double the radius, right? So if I look at it from that perspective, this distance going across here is the exact same as that distance, right? So that means that the height is equal to 2r. And for the best cylinder, we have some formulas. The best cylinder, we developed these formulas in class yesterday. The area of the best cylinder is 6 pi r squared, and the volume of the best cylinder is 2 pi r cubed. Those are the best, that's the best volume and the best area. Okay, by best we mean for any given volume, that's the least amount of area you're going to get, and for any given area, that's the most volume you're going to get. Okay, so what do I know about this best cylinder? Well, I know it has to hold the same volume, right? That's the whole idea here, is that I've got a volume of a really wide and short cylinder that's 452, and I'm trying to make a new cylinder that holds just as much stuff, so the same volume, but has a lot less area. So I know that its volume is 452.39 centimeters cubed. So now do I have an equation that I can solve? Well, if I look, again, I can go through these formulas. I don't know the area. I don't know the radius. I do know the volume. I don't know the radius. So is there a formula there that I can solve? I have to have one unknown in an equation to be able to solve it. Well, it looks like that one there is the equation I'm going to pick. So I know that the volume, V equals 2 pi r cubed, but the volume is 452.39 centimeters cubed. And that's going to be equal to 2 pi r cubed. So we're back to solving an equation with inverse operations. Bed mass inverse. So first thing I would do is cube if I had a number for r. The next thing I would do is multiply by 2 pi. I multiply by that 2 pi. What's the inverse of that? Opposite order, opposite operation. Divide by 2 pi. Then I would cube root. And in this case, I'm actually going to do the calculation. I'm going to show you the calculations you need to put in your calculator. Because if you don't use that fraction bar in your calculator or put brackets around what you're dividing, you're going to make mistakes. So we would divide that by 2 pi. And when I divide 452.39 by 2 pi, I would get 72. And then when I get 72, I have to then do the cube root of 72. And it works out that r is 4.16 centimeters. So now let's go back and label that diagram. So that's going to be 4.16 centimeters to go from there to there. And the height then is twice that, so that would be what, 8.32. I don't need these dimensions, but I just want to give you an idea what it looks like. Whereas, so that's the best possible cylinder in terms of saving surface area. The other cylinder, remember, was like 12, a radius of 12 and a height of just 1, right? So it was long and thin, much bigger than that, obviously, comparative to the drawing I've got above. But you get the idea. So the radius is 4.16. Well, do I have a formula? Sorry, I'm moving that around a fair bit. Do I have a formula here that I can use to figure out the area of the best cylinder? Well, there it is, 6 pi r squared. So I know the area of the best shape, the most efficient shape, is 6 pi r squared. So 6 circles. The area of that cylinder is 6 circles. Really interesting. So 6 times pi times 4.16 squared. And that's going to work out to, the area of the best one is going to work out to 326.23 centimeters squared. So finally, let's compare these. So here's our original. The original cylinder, the best cylinder. So the original one was like this. Okay, and again, this is like a cylinder like so, right? So it had a radius of 12 and a height of 1. On the other hand, the best one had a radius of 4.16 and a height of 8.32. Okay, the one on the left is the original, and then we have the best one. What was the same about both of those cylinders? The volume. The volume for both of those was 452.39 centimeters cubed. 452.39 centimeters cubed. So they would both hold the same amount of a juice or chocolate or some present inside. The volume's the same. The space, the 3D space is the same. But the amount of paper it would take to wrap that is vastly different. The area of the original one, was 980.18 centimeters squared. But the area for the best one was only 326.23 centimeters squared. Okay, so that's the big idea here, is that the one on the right, the best one, only has an area of 326.23 centimeters, whereas this one takes 980 centimeters squared to wrap. So in terms of cost, this one is actually almost 3 times as expensive to wrap because the area is 3 times as big. Okay, so they hold the same amount in 3D space, but they sure do have different amounts of area. Okay, so what I'm going to do now is stop this one. I am going to do one more screencast. It'll be quite a bit shorter where we figure out how much area a cube would have or a cylinder would have with this same volume. So again, remember, rewind, go over this screencast again. I know it's a long one at 16 minutes, but you may want to look at it again. Okay, hopefully that helped.